Hello everyone. Okay, so in this video we are looking at distance, displacement, velocity, and acceleration, distance, acceleration in relation to calculus. So, all we need to know is, so as we said, calculus is the study of rate of change, right? And what better example to study rate of change is by looking at distance, speed, time, what is acceleration. So, S is known, so we label distance or displacement as S. And the rate of change of your distance with respect to time is t. It's t, speed. It's just speed, right? That tells you how fast you can change your distance in relation to time. That's your speed, how fast you were going, right? And then the second derivative, or the rate of change of speed, is your acceleration, right? So if you can be speeding up or you could be slowing down. So acceleration determines how fast your speed or is increasing or decreasing. Let's look at a few definitions before we start. So displacement is a little bit different to distance. So we always learned in the junior leaving cert that distance is positive. We can't have negative distance, right? But the thing with displacement is defined as the distance relative to a particular point. So say, for example, this dot on the ground is my reference point. Jenny here is 6 meters to the left and John is like 4 meters to the right. So we say Jenny is minus 6 meters from the reference point and we say John is 4 meters from the reference point, right? So that is all that it means there. So negative displacement, position to the left of the point. Example, Jenny went 6 meters back. Displacement is minus 6. And positive displacement is to the right of the point. Example, Johnny went 4 meters forward. So velocity. Velocity is the speed relative to a particular point and its rate of change of displacement with respect to time. So the first derivative of ds dt. If it's greater than 0, velocity is greater than 0, that means my object is moving forward. If it's less than 0, my object is moving backwards. And if something is said to be at rest, that means the velocity is 0. So velocity as a rate can be positive or negative, but speed is always positive. So we have velocity, we also have speed. So velocity, again, like displacement, is in reference to a particular point. So Jenny here would probably be going like negative 6 meters per second, and John probably going positive 4 meters per second from that particular point. And finally, acceleration is the rate of change of velocity with respect to time, called acceleration. So let's have a look here. As soon as it touches down, an aeroplane applies its brakes. The distance s which the plane has traveled along the runway at any subsequent time t is given by this function. St is equal to 200t minus 4t squared, where s is measured in meters and t is in seconds. The distance traveled after 10 seconds. So just sub in 10. 200 times 10 minus 4 times 10 squared is equal to 2000 minus 400, 1600 meters. Right? Now, the speed of the plane at t is equal to 10. The speed of the plane that we're looking for, ds dt, that is 200 minus 8t, and then t is equal to 10. That'll be 200 minus 8 times 10 equal to 120 meters per second. So after 10 seconds, the plane is traveling 120 meters per second. This plane's speed as it touches down. So when it just touched down, t is 0. So we want to find the speed when it landed at. So the first derivative and let t equal 0. So 200 minus 8 times 0. So 200 meters per second. When the plane stops, its speed will be 0. So how long did it take for the plane to stop? Speed is 0. So 200 equals 8t. T would be equal to 200 divided by 8. 25 seconds. Then finally find the distance when the plane stops. So when the plane stops, t is equal to 25. So we're looking for how far the plane has traveled. So it's S25 is equal to 225 minus 4 times 25 squared. (2,500 meters). So the plane traveled a total of 2,500 meters on the route. Right, let's look at some exam questions. This is from a sample paper. So the distance traveled by an object is given by s equals 12t minus 2.4t squared. Find where s is meters and t is in time. Find the speed of the object. Well, ds dt is equal to 12 minus 4.8t. Then we want to find that at t is equal to 1.25. So that is going to be equal to 6 meters per second when we sub t in. And how long does it take for the object to stop? Well, when it stopped, its speed is 0. So 12 minus 4.8t is equal to 0. 12 is equal to 4.8t. T is equal to roughly 12 divided by 4.8, which is 2.5. Right. Have a look at this one. Fiona, it is 2023. Fiona is driving on a motorway. She passed the point A on the motorway. Her speed is given by this function. Work out Fiona's speed when she passes the point A. So where V is her speed in kilometers per hour and T is the time in minutes after passing the point. Well, if she just passed the point, T is 0. So when T is 0, so this will go to 0, this will go to 0, this will go to 0. It's 109. 109 kilometers per hour. Work out Fiona's acceleration. Well, that is just the derivative of its speed. That would be 2t squared minus 12t plus 13. 5 minutes after passing the point. So it's going to be at t is equal to 5. So 2 times 5 squared minus 12 times 5 plus 13 is equal to 3. Acceleration is 3. Then find the time value t where Fiona reaches her maximum speed. So her maximum speed, first derivative is equal to 0. So 2t squared minus 12t plus 13 is equal to 0. 2t. Give your answer correct to 2 decimal places. That's telling me I have to use my minus b formula. A is equal to 2, b is equal to minus 12, c is equal to 13, minus 12 plus or minus the square root of minus 12 squared minus 4 times 2 minus 13 times 13 all over 2 times 2. And I get here d is equal to 4.58 and t is equal to 1.42. So, but it says here within the first 4 minutes, so we reject that answer. So my answer is 1.42. And finally, last one here says 9. An object moves in a straight line such that its distance from a fixed point is given by this. Find the speed of the object. Well, we can rewrite this as t squared plus 1 to the power of a half. So, speed, first derivative. We're going to be using chain rule. So it's a half times t squared plus 1 times the derivative of inside, which is 2t. And we're finding that out at t is equal to 5. So if we sub in 5 here, we owe them minus a half on top. I do apologize, right? Bring the half down in front, minus a half on top. So 1 minus a half is minus a half. So that will be equal to 2t over 2 times the square root of t squared plus 1, which will roughly be t over root t squared plus 1. Sub in t is equal to 5. We'll get here 5 over square root 26. Answer. All right. I hope this video was, I still helped you guys. I'll catch you. Bye.